Alright, welcome Webster Groves. This is the Electrical Energy Unit, Goal 6 video notes. In this goal, students are going to be able to describe how electrical energy can be affected as it moves through a circuit. So this means you are understanding the effects of the resistance, the effects of an increase or decrease in volts, and the effects of a kind of material in the circuit and how that's going to affect the circuit. If you're going above and beyond the goal, you are able to look at a circuit or a circuit drawing and explain what you would do to increase or decrease the number of volts going through the circuit. Here we go. So factors that determine resistance are the material that you use. We already talked about this, insulators and conductors. We know that the material you use is going to affect the number of volts that go through. The length the electricity has to flow will affect the resistance, and the diameter of the wire and how that affects resistance. Alright? So, first we need a good understanding of Ohm's law because this is going to give us resistance. So, Ohm was this guy in the early 1800s in Germany. He was a physicist, George Ohm, and he said that the electromotive force acting between the extremities of any part of a circuit is the product of the strength of the current and the resistance of that part of the circuit. So this gives us amperes divided by volts equals resistance, or ohms. Okay? Or we can put it in this nice triangle. So what this triangle means, how it works, is like this. Okay, so amps divided by ohms, let me back that up. Amps divided by volts equals ohms. Or we could say amps divided by ohms equals volts. Or we could say volts times ohms will equal amps. Okay, that's how this triangle works. It's pretty handy. I will always give this to you so you don't have to memorize it, but it's up to you to know how to use that. Okay? So know how to use it and you'll be in good shape. So this is how you determine resistance. And remember, we learned this in a previous note set that resistance is the push against electricity flowing. Okay, it's resisting the flow of electricity. So what does voltage do? Well, if voltage increases, resistance decreases. Okay, and that makes sense because if we increase this number, okay, say the number up here is 1 for amps. We'll just make it simple. And say the number down here is 3 volts. Okay, so 1/3. All right. But if we increase the number of volts and we change that number to a 9, 1/9, then the overall resistance decreases. Okay, it makes mathematical sense. So we have 3 batteries. We have a 1.5 volt AA battery, a 9 volt battery, and the 6 volt batteries like you've seen in class. Which one would lower the resistance the most? I hope you're saying the 9 volt battery, because the 9 volt battery has the most volts, therefore would give us the least resistance. Okay, so quick video about a paper circuit. That's right. So if you have the right kind of pencil lead, you can actually make a paper circuit. Now this guy's drawing a variable resistor. A variable resistor is like a dimmer switch. Okay, you can change the number of amps going through the resistor, and it changes the output of electricity. So much like you can change how bright a light bulb is on a dimmer switch. Okay, so we've got a 9-volt battery, we've got a drawing pencil that is graphite. Okay, we can see this is an LED bulb and there's a little resistor on there. He's testing it out, make sure it works. Okay, it works. So he puts one end of the LED on one end of the pencil lead, wire on the other, and we can see that that conducts the electricity. Okay, my point is this only works with a 9-volt. It's not going to work with a 6-volt. It's not going to work with a 1.5 volt because the higher voltage decreases resistance and allows this to work. Otherwise, you would not have enough push in this pencil lead for it to work. The 9-volt is the only one that really works. Okay, so length. How does length affect things? Well, if you have more length in your wires, you're going to have more resistance. So that means if we shorten the length, okay, between the battery and the light bulb, it's going to get brighter. And if we move the light bulb back, it'll get a little dimmer. Now, this is a very tricky thing because it depends on what these wires are made of, how thick they are, but the length of wire does affect resistance, and you have seen that in class. The longer the wire, the more the resistance, and vice versa. The shorter the wire, the less the resistance. All of these relationships today work in the opposite. Okay, it affects the type of material. We've seen this. There are better conductors that have greater resistance, and worse conductors that have more resistance. Okay, so the better the conductor, the lower the resistance. The worse the conductor, the greater the resistance. We have different types of wires. Okay, so copper is known to be the best conductor, so it's going to have the least resistance. But copper prices have gone up, so a lot of people are considering, what about aluminum? Should we use aluminum? And there have been a lot of tests, and some people would say aluminum is just as good. Some people would argue with that and say it's not. So the better the conductor, the less resistance you have. Effects of wire diameter. Okay, you can have all different diameters of wire, basically like the thickness of the wire. Often the wire thickness is measured in gauge. Okay, so wire diameter. If wire diameter increases, the resistance decreases. Think about a garden hose versus a fire hose. Fire hose is thicker, there's more water flowing through it, there's more water allowed to flow through it, so you're going to have more water go through the fire hose. Less water through the garden hose because it's not as thick. It can't allow as much water going through it at once. The fire hose can allow a lot more water going through it at once. Same kind of thing. The wire diameter, the thicker the wire, the more electrons can move through it at once. Smaller the wire diameter, the fewer electrons can go through it at once. Okay, so the effect of the wire diameter on heat. Okay, we have steel wool, and we're going to have a 9-volt battery. Okay, don't try this at home without adult supervision. But we can see that since the steel wool, those fibers, those steel wool fibers are so thin that when we put electricity through them, they cause a lot of heat and can actually like catch on fire. So what does this mean about resistance? Well, we know that those steel wool fibers have a lot of resistance because they're very small diameter. They're very small diameter because those fibers are very thin. And so there's going to be more resistance because wire diameter is going down in this case. Okay, so the effective resistance goes up, equals heat will go up. You have seen this in the incandescent older light bulbs versus the newer light bulbs, okay, the more energy efficient light bulbs. So this tungsten filament right here that has to light up in order for the light bulb to work, it has to have a lot of electricity flow through that tungsten filament in order to get the light to work. So there's a lot of resistance here. And since there's a lot of resistance, there's a lot of heat that is given off. If you've ever touched one of these light bulbs after it's been on for more than like 10 seconds, it's pretty hot. And then it's a lot different once you get these energy efficient light bulbs. Here we are passing electricity through a gas and there's not as much resistance going on. So it's not going to be as hot. And as a result, you don't have to pump as much electricity through this energy efficient light bulb to get the same effect. So the relationship here, resistance goes up and heat will also go up. Okay? Alright. This I'm going to leave up to you to answer. What would you do to increase light bulb brightness in this parallel circuit? What would you do? Tell me 3 things in your notes that you would do to increase the light bulb brightness. Okay? So think about all of the relationships we've talked about. Okay? Think about wire diameter. Think about length. Think about the type of material. Think about voltage. What would you do? Alright? I will leave that up to you. And that's all we have for today. Thanks for watching, and if you have questions, bring them to class.